Okay, good afternoon all, and welcome to the first of this new series of energy efficiency webinars. My name is Peter Halloway. I'm a regional sales manager for Chauvin Arnoux UK, and I'm joined today with John Mitchell, who's a sales and marketing director for CP Automation.
Hello everyone, thanks for attending.
So I, along with other members of Chauvin Arnoux, used to go around the country and we would perform seminars before COVID obviously hit us all. So now what we've done is, that used to be about an hour and a half, and we've had that turned into a webinar, had it professionally voiced over by Dave Austin, who's quite renowned in industry for that type of thing. And there's some really good, compelling stuff. So the lineup for today after this introduction will have the video of the webinar, which is about 22 minutes long. And then I really want to hand it over to John, because not only is John a distributor of ours, he's also a user of the equipment. So he can give things from a user's perspective. So that'll be quite good. And then we will open it up to questions and answers. And just to let you know, we are recording. We'll probably put this on YouTube. So as I say, there will be opportunity for questions and answers.
So while Pete's getting the video queued up, guys, I just wanted to let you know there is a chat function for those who are not that familiar with Zoom at the bottom of the page. You can click on there, you can put in your questions, anything that comes to mind throughout the video or anything that we discuss. And at the end, we'll review the questions and feedback to you. If you're unsure about that and you want to speak offline about it, then by all means, you can email us your questions afterwards and we'll get back to you. Over to you, Pete.
Okay, thanks, John. Okay, let's play this webinar and then we'll come back to you shortly.
If you are a business owner or facility manager and you want to save money, then this is for you. If you're an electrical contractor and want to learn about a lucrative new service, it's for you too. We're going to show you where you're likely to be wasting energy and how much. And we'll show you how to identify, locate and resolve the various issues and make big savings. Now, if saving money or earning more cash with a bit of planet rescue thrown in is of no interest to you, then you may as well move on. You won't enjoy this. Electricity consumption in the UK rose from 192 terawatt hours in 1970 to 301 terawatt hours in 2017, and that's a lot. Our future energy needs are open for debate, but all four scenarios currently being considered by National Grid will require us to create more generating capacity and, as importantly, use less electricity. But to put the numbers into perspective, the predicted additional capacity requirement just for electric cars by the year 2030 is between 3.5 and 8 gigawatts. And that's on top of the existing peak demand of 60 gigawatts. Now, by comparison, Hinkley Point C, the nuclear plant in Somerset, will add just 3.2 gigawatts of capacity to the system. So adding more is a big problem. It's clear the wiser way to go is reducing our electrical consumption. And the only way to do that is to improve our energy efficiency. Now, it is perhaps not surprising that nearly half the UK's electrical energy is used by industrial and commercial consumers. This amounted to 166 terawatt hours in 2017. It stands to reason, therefore, that any improvements in their efficiency could dramatically reduce our required generation. A saving of just 10% would amount to 16.6 terawatt hours, which is roughly equal to all of the energy generated by the UK's 5 remaining coal-fired power stations in 2018. From another angle, it equals nearly a third of the UK's entire wind farm generation output of 2018. To push businesses to become more efficient and to help us to meet our future energy needs, the UK has 2 items of legislation. ESOS is a mandatory energy assessment scheme for organisations in the UK that meet the qualification criteria. And SECR, the UK government's streamlined energy and carbon reporting policy, was implemented on the 1st of April 2019. These regulations require an estimated 12,000 companies incorporated in the UK to disclose their energy and carbon emissions. Apart from legislation, there are also moral advantages to reducing emissions, which of course also reduces a business's carbon footprint. But while it's good to improve your green credentials and shout about it, for many the biggest motivator will be the financial savings they can make. Energy is getting more expensive. Renewables are not cheap, and we're all paying for it with every unit of electricity we consume. The UK's wholesale electricity price rose from £19 per megawatt hour in 2003 to £46 per megawatt hour in 2017. So a 10 or 20% reduction in electricity consumption could save some businesses thousands of pounds per month. Reducing electrical energy consumption by 20% or more is easier than you might think. In researching the opportunities available to businesses to reduce their electrical energy consumption, some startling discoveries were made. According to the Carbon Trust, on average, 20% of the electricity consumed in businesses is wasted due to inefficient equipment. A British gas survey of electricity smart meters in 6,000 SMEs showed as much as 46% of electrical energy being consumed out of hours. Research shows, on average, businesses can reduce their electricity consumption by 12% by turning off office equipment at the end of the day. And office equipment left on standby during bank holidays and weekends cost the average SME £6,000 per year. On average, 25% of an organisation's electricity costs come from lighting. Occupancy sensors can reduce this by nearly a third, with daylight sensors offering even greater savings. And LED lighting consumes 80% less power than incandescent lamps for the same light output. Amazingly, studies have shown that 50% of businesses have poor power factor, consuming an additional 30% in unnecessary reactive power due to power factor levels of 0.7 and lower. And that's not to mention the effects of phase imbalance or high harmonic currents. These statistics come from the Department for Business, Energy and Industrial Strategy, the Carbon Trust, British Gas and National Grid, and are backed up by genuine research. Now, based on these, it's easy to see how reductions and therefore savings of 20% or more could be achieved. It's worth mentioning at this point that it is possible to reduce electrical energy costs by using one of the many price comparison businesses that are out there. Now, many organisations do this as the savings are easy to see and achieve. But in reality, they may generally only add up to a few percent, and it does nothing to reduce a business's actual electrical consumption or carbon emissions. Consider if your car was only doing 10 miles to the gallon, and you noticed it was leaking fuel on the road. Would you fix the problem or ignore it and look for cheaper fuel? Now, you're sure everyone wants to buy their fuel from the cheapest place, but it would make sense to fix the car first. And it's the same with the electricity a business uses. I mean, by all means, shop around for the best price. But in light of the previous statistics, far greater savings are to be made by fixing the problems. Let's look in more detail at some of those statistics and the more common electrical inefficiency issues. Motors consume around 40% of all electricity used worldwide and account for more than 2/3 of the electricity consumed by industry. Now, their performance degrades over time, and combined with advances in technology over the past few decades, replacing old motors can easily improve efficiency by 20 to 30%. The cost of running a motor for a year can be 10 times what it costs to buy it in the first place. And most replacement programs will have a payback time of 1 to 3 years. The efficiency of your motor operation is therefore critically important if you're aiming to lower your carbon footprint and reduce your energy bills. And for businesses that think they don't have any motors, what about the heating, ventilation and air conditioning? HVAC can use a huge amount of energy, enough to double a building's energy consumption and associated carbon emissions. How old are the motors pumping the water and blowing the air around your installation? It's also the case that older HVAC systems often operate motors at full speed, using baffles to restrict airflow as required. More modern systems, with motors controlled by variable speed drives or VSDs, will reduce motor speed instead. And on the basis that a motor running at 80% consumes 50% less electricity than at full speed, this can be another area where large savings are possible. Old IT equipment is another common inefficiency issue in offices, including photocopiers and printers. And there are still a large number of old PCs out there with old cathode ray or CRT displays that have been controlling industrial equipment for decades and still are. But at what cost? An LED monitor can consume 4 times less energy than its CRT equivalent, and often even 25% less than fairly modern LCD displays. With lighting contributing to 25% of the average industrial facility electricity bill, and with office buildings and call centres using even more, the efficiency of lighting equipment and its use is vital. Obvious changes are to move from incandescent lamps to LED, with savings of up to 80%. Less obvious are the effective use of occupancy sensors and daylight saving devices. Occupancy sensors in occasional rooms like meeting rooms, corridors and bathrooms can cut lighting costs by 30% by ensuring areas are only lit when they're in use. And with daylight sensors adjusting artificial light levels as the sun comes up and goes down during the working day, a business can save a further 40%. Shockingly, 46% of the electrical energy used by UK SMEs is consumed out of hours, according to a survey of 6,000 smart meters. That's nearly half the electricity used by a business. One of the most common causes is office lighting left on at night and weekends, something you can often see for yourself as you travel around at night. Similarly, car park lighting. Being outside, it's often overlooked. Car park and other external floodlighting can sometimes offer the greatest cost-saving opportunities. Halogen floodlights can be replaced by LED equivalents, and the use of occupancy and daylight sensors will ensure that no energy is being consumed unnecessarily. Another culprit for out-of-hours electricity use in offices, call centres and classrooms is that of equipment being left on all night and at weekend. This ranges from the obvious PCs, monitors, photocopiers and printers to hot water and other vending machines. Disappointingly, 50% of businesses have poor power factor, many as low as 0.7, consuming an additional 30% in unnecessary reactive power. Now, if you don't already know, some electrical equipment requires an amount of reactive power in addition to active power in order to work effectively. These tend to be items with copper windings in them, especially transformers, motors, induction heaters, arc welders, compressors and the like. Even fluorescent lighting. Now, it gets a little complicated. Stay with me, we may need beer. Real power, known as active power, performs the real work in a piece of equipment. Reactive power does not perform any useful real work, but is necessary for inductive loads to work. It also takes power away, making it harder for the real power to supply the load. Apparent power is the vector sum of real power and reactive power. Let's attempt an explanation with the help of a pint of beer. If the explanation doesn't work, at least we can drink the beer. When you order a pint of beer, you pay for the entire contents of the glass, the apparent power. What you want is mostly beer, real power, with a little froth on the top, reactive power. If the froth is too big, as with this pint, then there's less beer in the glass, but you're still paying the same price. A little froth is of course fine. In fact, it's necessary. Now, it's similar with reactive power. While it's okay for a little to be there, if there's too much, then the consumer will be paying for it in reactive power charges or penalties. Power factor is the ratio of the active power to apparent power, and is used as an indication of how efficiently power is being delivered to the loads in an industrial or commercial site. A power factor of 1 is ideal, but almost impossible. It's like a beer with no froth. A power factor of 0.95 is generally accepted as being as good as you can get, and something to aim for. And this would be a beer with a perfect amount of froth on it. Now, to achieve this, power factor correction, or PFC units, are connected to the installation. In its simplest form, this consists of a selection of capacitors of calculated values that automatically switch in and out as changes in the operating load require. The capacitance basically counteracts the effects of the inductance in the load. With modern equipment, it's not quite as simple as that, due to the need to consider harmonics and other power quality issues caused by non-linear loads, and we'll touch on these later. Either way, there are two common issues that result in 50% of UK industries having inadequate power factor correction today. Firstly, PFC equipment calculated to suit the loads in the business at a point in time may no longer be appropriate as time passes. This is mostly due to new equipment being added and old equipment being decommissioned. And secondly, and perhaps more significantly, the capacitors in power factor correction equipment wear out over time. Since PFC units generally sit out of sight and out of mind, and with much electrical work nowadays being subbed out to contractors, there appears to be an increasing loss of ownership and knowledge of the complete electrical installation by any one person, including power factor levels. Phase imbalance occurs when single-phase loads are unevenly balanced across the three phases of an installation. Often, like power factor correction, the phase loadings would have been balanced and checked when a facility was first designed, or when the initial installation was performed. But as time passes, it's common for the original loads to be moved or decommissioned, and new single-phase loads introduced. Now, if this is done without consideration or knowledge of the load spread across the three phases, then over time, significant imbalance will occur. Heat losses in cables and equipment are proportional to the square of the current, using the formula I squared R. Imbalance phases mean high currents on phases that should be shared better across the others. Phase imbalance also has serious implications for any three-phase motors in an installation. It can cause phase current up to 10 times the percentage voltage imbalance for a fully loaded motor. So a 1% increase in voltage on one phase will potentially cause a corresponding 10% increase in current drawn on that phase by all of the three-phase motors connected to the same installation. Now, this not only equates to a 10% increase in energy consumption, but could lead to overheating of the motor windings and shaft vibration, both of which will shorten a motor's life. Harmonics and other power quality issues are the subject of another one of our presentations, so here we'll just consider their effects on the electrical efficiency of an installation. Harmonic currents are generated by non-linear loads like variable speed motor drives, LED lighting, IT equipment, UPS systems, and solar PV inverters, to name just a few. Harmonics create all sorts of problems in an installation, but with regards to energy efficiency will, at the least, create increased internal energy losses in connected equipment. Resistive heating is proportional to the square of the harmonic order, so it also follows that the greater the number of higher order harmonics that exist, the greater the heating effect. And this transposes into increased energy consumption and reduced equipment life. Now, as with all the energy efficiency issues discussed so far, the effects of harmonics can be mitigated in various ways, but you need to measure them first. So, having highlighted a variety of potential energy efficiency issues, the next step is to see what's actually happening in your installation. Or if you're a contractor offering energy logging and efficiency improvements as a service, what's happening in your client's installation. And the best way to know that information is with a power and energy logger. This will allow measurement and, more importantly, logging over time of three-phase currents and voltages with automatic calculation of power factor and measurement of harmonics up to the 50th order. Simply connect it to different pieces of equipment or machinery or even whole circuits and leave it logging for a while. The electrical consumption of equipment and machines can be compared against rating plates to look for degradation over time and against the specifications of new replacement items for increased savings. Measurement over days or even weeks of individual circuits will identify the costs of out-of-hours electricity use and enable savings calculations to be made. These can then be used for the justification of equipment upgrades, like moving to LED lighting, for example. A good way to start the journey to improved energy efficiency would be to log the usage of the site as a whole over, say, a week, and then home in on problem areas by subsequently logging individual circuits. Connection is non-intrusive, and assuming the operator is qualified for live working, there is probably no need to turn the power off at any stage. Current measurement coils simply loop around cables. Voltage leads can be clipped onto conductors, or magnetic probes used for easy connection to MCB screw heads. It's easy to set up and monitor results using the free app. And logged measurement data can be downloaded via USB cable or directly from the SD card for analysis on a PC using the included reporting software. If it's your business, when you're finished analysing the installation and its contents, you can semi-permanently connect the PEL up at the incomer and plug it into the IT network. And from that point on, live data will be continuously monitored. This will immediately highlight any new issues with power factor, phase balance, harmonics, and ongoing electrical consumption in and out of hours. Now, if further investigation of any item is required in the future, the PEL can be disconnected from the incoming supply, used to temporarily monitor the item or circuit, and then reconnected at the origin afterwards. This is arguably a better solution than fixed monitoring equipment, as there's no holes to cut or any need to turn the power off for installation, and the PEL can be moved around as required. If you're an electrical contractor, there is a great opportunity to offer services to business owners who want the green credentials and to save money based around efficiency measurement, but don't know what to do. You can offer the lot: energy logging over time, power factor measurement, phase balance measurement, harmonic analysis, or a complete energy efficiency logging service. Chauvin Arnoux UK are here to help. We've created a media channel at CA UK TV. There you'll find a series of how-to videos that show you how to set up the PEL, how to connect it to an installation or piece of equipment, how to start a logging session, how to download results from the PEL, and how to use the app. There are also more than 20 technical articles and a white paper detailing various aspects of energy efficiency and power quality. And if you need more help, our staff and business partners are always there to provide personal support. So if you're a business owner or the manager of a facility or campus and ready to reduce your electrical consumption and carbon emissions while making significant financial savings, or if you're an electrical contractor and ready to add a lucrative new service helping businesses reduce electrical consumption and carbon emissions, take the first step now by visiting CA UK TV. Alternatively, contact us directly on info@cauk.tv or call us on 01924 460 494. See you soon.
So hopefully you found that very enlightening. Dave really covered what both John and myself have seen quite often when I've had the privilege to go out to customers and they connect an instrument and we look together at their site. Then I'll often see power factors way below 0.7 and harmonics and all sorts of other issues, as was mentioned, and certainly saving 20% is probably quite the norm and quite easy in many installations. As I said earlier, what I'd like to do now is hand it over to John because John's going to give a user's perspective on the instrumentation and what he likes about it and what's in the kits and why. So over to you then, John.
Right, yeah. Basically, obviously, we use this equipment ourselves. Our engineers and our teams are using this to help customers. We use it to help solve problems, look into problems, diagnose things, compare what the customer thinks they're reading, and that sort of thing. So what we did was, in our experience of using this kit, after a few different visits that we've done at different, many different installations, we realized that just buying the things we need wasn't always the best way to do that, because we get to site and trip up on something where, okay, all the cables are slightly different. They're coming into the panel wider than we thought, so we haven't got exactly what we need. So what we did was we worked with Pete and said, look, I want to put a kit together for people to make it a lot easier for them to understand what they're doing. And we'll go into that a lot more in another seminar in terms of how you use it and whatnot. But I just wanted to give you an idea of what the kit looks like, which Pete's kindly put up on the screen here. So you can see on the screen, you've got the PAL. And in the kit, we add this power adapter that you can see just at the bottom left of the PAL there that he's highlighting. That enables you to power the PAL directly off the mains from the supply, instead of having a single phase connection, because more often not in the panel, you're never going to find a 3-pin plug or a 2-pin plug, depending on where you are in the world, to get off the single phase. So this enables you to just 2-phase the unit, supply off the 3-phase that you're already connecting to, which makes it nice, neat and simple. One less thing to worry about. The second thing is, as you can see there in the picture, and you saw in the video from Dave's presentation there, that we do these Rogowski coils, right? So they're good for like up to 10,000 amps. But what we found on some sites is that there's multiple cables coming in on a single phase. So they've split the cores out and you've got multiple cores coming into each of the phases. And that becomes quite a problem sometimes. So on small installations, it's perfectly fine. But when you need to get maybe further upstream, that can become a problem. So what we've done is we've put together an 800 mil. So this is the 350 mil clamp, but we do an 800 mil clamp, and we've upgraded the kit for free basically to offer you this as a solution to your problem. You don't have to choose it this way, but we prefer it because it gives us much more flexibility when we get to site and realize that something's not quite how we'd hoped it would be from a connection point of view. Just little trip hazards that have come along the way. Additionally, we've got these magnetic reeling clamps. You probably can't see these that well, but Pete's highlighting them on there. And what you do with those is you put your voltage leads that will connect to the PAL. Let me just take this one off. This end of the voltage lead will connect into the PAL. You just undo it, stick it on the panel. The other end has got a crocodile clip if you want it, or as we've added to the kit, you can see there on the left there, magnetized probes, and these are perfect, as you saw in the video as well, to go into the MCBs, because you're measuring voltage. You don't need to do that on the main bus bar. You can measure that anywhere in the panel and clip straight onto there magnetically. Again, non-intrusive. You don't have to disconnect anything. Really nice solution for that, really. I didn't really mention, but again, you saw in there that the PAL itself is magnetic, so you can stick that on inside the panel, upside down. We've had them stuck to the roof of the panel. It doesn't matter where you put them. Keeps all the cables nice and out of the way. In addition to that, in the kit, you get a tablet. On the tablet, you've got the app for the device, so you can check things like phase rotation. Even though there's an indicator there, you can actually see the phasor diagrams to make sure you've connected the device up the correct way, that the CTs are connected the right way, so all your power and energy data is correct. More often than not, we get sent information from customers, and we'll talk about that a little bit later, where the data's wrong, and that's usually because someone's misconnected the CTs. Anyway, moving on from that, basically the whole kit, you get the data view software, you can highlight there as well. So you can do reporting functions, so you can take pictures and snapshots and data from the pad and record those and save that data, but also the recording inside the PAL you can use with the data view software to create custom reports for your customers based on the data you've recorded over that time period. And you can even screenshot that data and put it into your own personalized custom reports if you prefer, using Word, Excel, and any other PowerPoint, whatever you're doing for a presentation. In addition to that, it comes in this nice bag that you can see there. Just to give you an idea how big the bag is. It's not massive. It's the perfect size. It fits absolutely everything in there. So it's quite compact and easy to use. That's it really from the kit. I will talk more about that in the following week, but back to you, Pete.
Okay, John, thanks for that. Just before we come on to the questions, we've mentioned next week there is a live demo. Same time next week, there's the link. When I email you, I'm going to email a few things out to you guys. I'll also email this link that takes you to the sign up page for the demo next week, where I'll be showing how you set one of these up and download results, and we can look at some results and all those fine things. Also, you may have some questions which you don't want to ask today, or you think of later. So my contact details and John's contact details are also there. So please, if you've got any questions, do come back to us. That would be great. Okay, so we have got a couple of questions coming in. John, do you want to cover the one on, I think there was one on LEDs. Do you want to cover that one first?
Yes, I believe my good friend in Texas, Jeff Edwards, asked the question. Let's have a look here. Do the surveys indicating how much energy is consumed by lighting and then how much can be saved switching to LEDs take into account those entities that have already switched to LED lighting? Jeff, that's a good question. The focus of the PAL is to record the information at whichever point of coupling that you connect to, right? So what the customer would, or whoever's doing the survey, depending on who they are, what they need to do is maybe they would first measure the main point of coupling, measure the total energy, and then go down to the individual branches. So maybe they'll look at specific lighting circuits and then measure those. And then from that, as part of their survey, I would assume that they would then go down to look at, okay, which ones have been upgraded, which ones haven't, to give some kind of compelling offering for that. That would be down to the people doing those surveys. And I think I kind of get your point where you might be going with that as well, because a lot of people maybe will just go and measure at the common point, not do a detailed report for the customer, and just give them a generic, well, you could save, and not be more specific. Now with the PAL, that gives you the opportunity that you can immediately take it off once you've done some recording there. It'll increment your next recording phase that you do when you set it up to record again by pressing the record button, and then that can be branch 1 and then branch 2 and branch 3. And while you're documenting that, you can be talking to the customer and surveying what actual hardware they have installed. So it's a great feature to be able to do that. I hope that answers your question, Jeff. If it doesn't, please email me and we can have a chat about it offline, buddy.
Okay, a couple more come in, and there's one here from Dave. Oh, great question here. Why do I need a PAL? Why can't I just use a clamp meter? Well, good question. Worth talking about clamp meters quickly, because we've just done a little bit of research lately. So what you got to be wary of with clamp meters is most of them on the market at best will only cover or measure AC currents up to about 400 hertz. Now that is the 8th harmonic. So all the other harmonic currents, and believe you me, there will be plenty of them that are above the 8th, you're not measuring that current. So if you were, I don't know, if you were looking at an installation for sizing conductors to make sure they're appropriate for the installation, then you wouldn't really be doing that job. So just because it's true RMS, it doesn't mean it's true RMS and it has the bandwidth capability to measure all those harmonic currents. To specifically answer your question, Bo, as in why not use one of these instead of a PAL? Well, this is great for something instantaneous, but what you tend to find is things are changing all the time. There could be shift patterns, different machines coming on and offline, HVAC systems. So you do need to log over a period of time, typically a week, but I would say you would talk to your customer and find out from them, because they might have different things happening over a longer period of time. So that's where you would talk to them. And if you look at something like EN50, I'll come to you, John. If you look at EN50160, it talks about a sample rate of about 10 every 10 minutes. But then you've got to think about how long do I want to log for as well. Sorry, John, what did you want to add?
No, apologies. Yeah, I was just going to add in there, really, I kind of explain it because we've had a few cases where customers have wanted us to come and do what you've just explained there, point on test, right? Take the clamp meter in and do a simple spot check. And it's good to do a simple spot check. And if they say this is like our normal operation, you get a feel for what's coming, but it doesn't show the whole picture, as you said, holistically with the plant through shift patterns and all of that. But in addition to that, I kind of liken it to like what they're asking for there when you go in with it to the clamp meter is an MOT. You've gone in and at that moment it passes or it doesn't, and that's all you know. But when you have to take into account the standards, you need to look that it's got to be applied over a period of time. and then you need to understand the total picture. So you could go in and think everything's fine, and we've had many cases where someone said, well, someone come in and they did a measurement and it looked great, and it's like, yeah, but the 500 kilowatt chiller wasn't turned on at that point. And you can see with a PEL that you can record over that period and go, okay, we see current and the voltage is stable, the current has gone up, the power has gone up, and now we start to see maybe harmonics or power factor being affected. And you can correlate it directly to what's actually happening on site. So it's quite powerful. You know, you can see a much bigger picture than just the spot check at that point. But the spot check is useful if your customer's quite sure that that's all that's going on plant, you know, which is never the case.
Got one here from Sachin. Sachin, you've asked about the video. Yeah, what I'll do is I am going to, in fact, I'll email Julian Grant, who's our UK General Manager at Chauvin Arnoux UK, has just written a great article regarding the clamp meter situation I was just discussing there. So I'll send you a link to that. I'll send you a link to the video as well, so you can look at that. And yes, I know you want to show your students. That's fine. All we ask is you obviously leave Chauvin Arnoux on it, so leave it in its current form, but that's absolutely fine, not a problem at all. And if there's anything else, I'll send you a link to the live, I'll send everyone a link to the live demo as well. We've also got, we've got new messages coming in. Okay, that was just, thanks, no problem, Sachin. Alan, how the calibration, how the calibration of a PEL 103 can be carried out aside a yearly one if a UCAS type certificate is required. Okay, just to explain to everyone then, most test instruments normally would come with what we call a certificate of conformity. Now that is that's basically means that the manufacturer's tested it in accordance to our spec and it passes. So that is effectively your first year calibration. If you need, because you're working for certain customers, if you need any additional calibration, so I know that there's industries out there that would want not even just UCAS, just a normal calibration certificate. Then if someone purchases a PEL 103, time of order, it can be additionally, there's an additional charge, of course, but you can have an additional calibration certificate, and we can always look at UCAS certificates as well. So yeah, it's all possible, Alan. So hopefully that has answered your question. And
I'll just add to that, Pete, as well. So after that, yearly calibration can be done by any of your preferred. We can put you in touch with. We have partners that do annual calibrations, so we can either handle it, or we can put you in touch with people. If you've got multiple instruments you want to get sorted, maybe you send them all in one go and get them all calibrated. So yeah,
there's plenty of avenues for calibration.
They're all familiar.
Doesn't necessarily need to come back to us. Right, was there, oh, there's another
One from Jeff. Can you see the one from Jeff there in response?
Yeah, no, that's okay. There's one coming, probably best that you cover this one, John.
Okay.
If I identify poor power factor or harmonics or other problems, how can I resolve these? What can I do to further investigate these?
Okay, yeah, that's a really good question.
How do I fix it, basically?
Yeah, absolutely. So that's a good question, because you have the PEL and you've done your recording, you've got the data. You might not be experienced at understanding or looking at that data, and we get customers send us files of recordings they've done all the time. Dare I say it, with other devices too, because obviously a part of our company's philosophy and strategy is to supply solutions, as well as our mission, if you like, of Mars, which is to measure, acquire, report and solve solutions, is that the file might not be understood in terms of what the data is, or you might not know how to use that data to be able to explain back to your customer what that data is telling you, right? That's where we come in addition to that, that you can go and do all the measurements with the hardware, you can share the file with us, we'll go through the file with you, explain what we're seeing in the file, and then feed back to you and say, oh, actually, this is really good, the customer's site looks great, or, oh, I can see a problem here, it may need further investigation, or there's a real bad problem here, and this is what we need to do. Let's get a conversation with the customer going around these points, structure that for you, and then we can make solutions and offerings should that be something that you're interested in providing for your customers. So all different variants of that we can help solve with. So there's many different ways to solve a problem as well. So it can appear in one way, but their power quality is quite symbiotic. So you can solve it one way and fix two things at the same time. So again, our experience in that can help you with that. Thanks, Pete.
Okay, no problem, John. Okay, I mean, if there's any more that come in or we miss any, we'll have a transcript of this. We will certainly come back to you anyway. And I've got a list of the people, I'll be passing them on to the CPD service. They won't do anything other than organise a certificate for you. So that's why we do that. Anything else to wrap up on at all, John? I don't think there's...
I don't think so. I can see there's one other question in there, but I'll come back to that person afterwards. It'll be easier. It's more specific to one thing, so it'll be easier to.
Okay,
not a generic question.
That's fine as long as you've captured it.
Let me just see. There's one thing here from Joe. Let me just see what Joe's put here. Good question, Joe. Actually, is there an unforeseen shutdown for whatever reason during the logging period? Will it affect the average power consumption measurement, or will the PEL ignore the readings for that shutdown period? That's a great question, and you know what? I wish I'd paid you to ask that question, Joe. That's a great question indeed. So, with the PEL, in fact, I'll probably have to buy him lunch now. With the PEL, what it does is when you've got it connected to the mains, it'll be recording and logging. Once the mains goes off, there is a battery in here, but the battery in here is designed to just handle the shutting down once the mains goes off and then come back online again as soon as the mains comes back on. And the idea of that is that you can't have any problems in your power network when there's no voltage applied or nothing's being consumed. So the PEL will go into standby mode, that we call it, like a shutdown mode, but for a period of time after that voltage has gone off, it will record, and then for a period of time when the voltage comes back on, it starts recording again. Your report and data doesn't change. All it shows in the report is that there was nothing happening in that period because the supply has gone off, i.e. a power outage or something. But it still allows you to record through like a power dip or things like that. We're talking about prolonged power outages. So yeah, good question actually. So yeah, absolutely, all the data's there throughout that file and that recording. Thanks, Joe.
Yeah, you'll basically the event log will tell you that there's a shutdown, and Joe, if you come along next week, we can share more detail on that, showing you some real files. Probably becomes even more obvious as well.
I'm getting a bit concerned now because I've got another question here from Chris, and it's asking. It seems like they're loading now. There's a question here about do you have solutions to solve harmonics and power factor issues? Yes, we do. Don't want to talk about it on here today, but yes, we've got a whole range of things to solve those problems you might see. Not just capacitor-based power factor correction, but we do digital IGBT-based, which is called an SVG, or harmonic filtering. But again, anyone wants to talk about that specifically, we can talk about that afterwards. Just email me and we'll get back to you. But we've got solutions for almost every power quality problem out there that we know today.
So yeah, you've got our contact details, so just send things through to us and we can get back to you, no problem at all. And as I say, I will be emailing you all anyway with various links, so you'll have my details. Okay, so I think that's probably it. I mean, thank you all for giving up your valuable time with us this afternoon, but by all means, if anyone wants to stay on and ask something, then just message us now. I'll just leave this open for a minute or two in case that is the case. But no, thank you again. And hopefully we'll see you again next week where you'll see it in action. Yeah,
we'll do a live demonstration. And hopefully we're going to do a series of these with different products about how they're beneficial and things that can help. But today was more about just creating an awareness about energy and hopefully sparking some questions. And from there we can speak in more detail individually, or we can go through and do one-to-one presentations and refreshers or anything you may have missed, because I've seen some people have managed to get on the call a bit later than they probably had planned due to other responsibilities and whatnot. So please just message us and we can do anything you want. Okay, thanks for your time. I really appreciate it, and hopefully speak to you soon.
Yeah, just finishing off on thinking, as I came from the educational sector, Sachin, if you noticed that Dave Austin mentioned our media channel, which is www.cauk.tv, for some fantastic technical articles. There's about 20 technical articles there that you'll be able to download for some really, really useful information. So please everybody make the most of what's there, because there is some good stuff there. That's what it's there for. So thank you. Okay, feel free to either hang around, or that's pretty much all we have for you this week. Thanks again.
Thanks, guys. Take care. Have a great weekend. Stay safe.